Good day, everyone. My name is Jane Smith C. Inopia, and I am Jerry Camille Sardido. We are here to talk about prepositional logic. Propositional logic. Conditional proposition. A statement that proposes something is true on the condition that something else is true. For example, if P then Q, where P is the hypothesis or antecedent and Q is the conclusion or consequent. Or in other words, P is the hypothesis and Q is the conclusion. So, this is the truth table for conditional proposition if P then Q. So, if P is true, then Q is true, the conditional proposition is true. Then, if P is true, then Q is false, the conditional proposition is false. Then, if P is false, then Q is true, the conditional proposition is true. Then, if P is false, then Q is false, the conditional proposition is true. So, conditional proposition can only be false if the conclusion is false and the hypothesis is true. So, here is the examples on how to determine whether the conditional proposition is true or false. So, A, if dolphins swim in the ocean, then birds fly in the sky. So, if dolphins swim in the ocean is the hypothesis or P, then birds fly in the sky is the conclusion or Q. So, in this statement, both hypothesis and conclusion are true, so the conditional proposition is true. B. If Los Angeles is in Oregon is the hypothesis, then the Mississippi River flows backwards is the conclusion. In this case, this conditional proposition is true because Los Angeles is not in the Oregon, the Mississippi River flows backwards. Regardless of the hypothesis is false, but the conclusion is true, the conditional proposition is still be true. C. If Jupiter is a planet is the hypothesis, then there are not any volcanoes on the Earth is the conclusion. So in this case, this conditional proposition is false because the conclusion is false while the hypothesis is true. Condition on the conditional. Contrapositive. If not Q, then not P. Converse. If P, then Q. Inverse. If not P, then not Q. So in writing the converse and the inverse and the contrapositive, example, A. If Howard can swim across the lake, then Howard can swim to the island. In writing this into converse, this statement will become, if Howard can swim to the island, then Howard can swim across the lake. Then in writing in inverse, this will make into, if Howard cannot swim across the lake, then Howard cannot swim to the island. And in writing this statement into contrapositive, this statement will become, if Howard cannot swim to the island, then Howard cannot swim across the lake.
Okay, I'm going to discuss about only if and the biconditional. To say P only if Q means that P can take place only if Q take place also. That is, if Q does not take place, then P cannot take place. It's vice versa. Another way to say this is that if P occurs, then Q must also occur. If P and Q are statements, P only if Q means if not Q, then not P. Or not Q implies to not P. It is equivalent to if P, then Q, or P implies to Q. Converting only if to if then, John will break the world's record for the mile in under 4 minutes. Solution. If John does not run the mile in under 4 minutes, then he will not break the world's record. This is if then statement. Why? Because we use here if and then here. Okay? So if John does not run the mile in under 4 minutes, or not P, because does not is equivalent to not, and this is P, so not P. And this is the symbol for if then. Or I shall read this implies to, not Q, because it is will not. Well, will not is not, so not Q. So not P implies to, not Q. Another version. If John breaks the world's record, then he will have run the mile in under 4 minutes. So here is not, it is P implies to Q. Why? Because there's no not here. So that is why it is P. And will here is Q. Definition. Given statement variables P and Q, the biconditional of P and Q is PF and only if Q. So, in the biconditional, P statement or here is F and Q statement here is only if. So, it is true if both P and Q have the same truth values, and is false if P and Q have opposite truth values. The words F and only F are sometimes abbreviated to F. So in short, not P, and this is the symbol for biconditional, and not Q is true. Why? Because they have the same truth values. So it is true. If they have opposite values, it is false. So P, if and only if not Q, is opposite, so it is false. Okay? The biconditional has the following truth table. So this is the truth table for biconditional, and this is the symbol for biconditional, or if and only F. So P and Q, or P and F and only if Q. There are two variables, so the formula is 2 to the power of n is equals to 2 to the power of 2 is equals to 4. So true, true, false, false, true, false, true, false. These are given. And we're going to find here, the value here. So P is true, Q is true. They have both the same values, so it is true. And P is true, Q is false. They have opposite values. This is false. Again, if in the biconditional statement, if they have both the same values, it is true, and if they have opposite values, it is false. Example, this computer program is correct if and only if it produces correct answers for all possible set of input data. Solution. If this program is correct, then it produces the correct answers for all possible sets of input data. Okay? This statement here is biconditional, and we're going to convert this into if then. So it goes like this. We use if, since we're going to convert this into if then, and here is then. So if this program is correct, then it produces the correct answers for all possible sets of input data, and here is so if this program produces the correct answers for all possible sets of the input data, then it is correct. So another if then statement here, but
We use and or conjunction.